Hello, and welcome to the presentation on timing and synchronization across a multiple number of industries, specifically focusing on the use of 1588 or the Precision Timing Protocol, PTP. The presentation is called Getting into Sync and is delivered by Calnex Solutions. What we're going to look at here is the number of industries that are looking at PTP or 1588 as the technology of choice for delivering timing and sync over Ethernet. This session will look at why these industries need sync and how PTP is being used to deliver that sync. We will start with the industry that has predominantly used 1588 the most, which is the mobile backhaul sector. Before we do that, let's look a little bit at the idea of a profile within the 1588 protocol. The IEEE, which specified the 1588 standard, also came up with the idea of a PTP profile. This is fundamentally a use model or use case for the 1588 or PTP protocol. The purpose of a PTP profile is to allow specific industries to define rules of PTP for their own industry. So, for example, the interworking and interop and performance requirements for a particular industry can be defined within these use models. And in general, we're stating this because the existence of a PTP profile usually indicates that the industry has developed and thought about how they're going to use PTP, in which case they're probably more advanced in the utilization and deployment of PTP. And the industry, of course, that is we mentioned earlier, is most advanced is the mobile backhaul sector. The mobile backhaul industry has defined a number of profiles specified under the ITU-T recommendations. Here, the G8265 recommendation, 8265.1 recommendation, which is about the transport of frequency synchronization across a network with no PTP timing support. The mobile backhaul industry also looks at 8275 or specified 8275.1, which is about the transport of PTP across a network for phase and timing synchronization, that network having full timing support. There's also work underway in terms of looking at the approach of deploying PTP with assisted or partial or partial timing support in that network for both time, phase, and frequency synchronization. So these profiles are specified and governed under the ITU-T recommendations that have been mentioned. And as I said, the mobile backhaul industry is probably the most advanced in the specification and deployment and utilization of PTP. But there are other industries that are very closely looking at 1588, and the power industry is one of them. Now, the power industry is predominantly looking at PTP to power the smart grid. Smart grid, of course, means lots of things to lots of people, but in this area of timing and synchronization, there are really two big drivers for better synchronization. One is the greater complexity of networks, going from big power generation stations and big consumers of power to a more complex network where power is being generated at lots of different points. You have solar panels on roofs, you have wind farms, and all of this needs to be coordinated. And that greater complexity and diversity means that you need a more coordinated approach to a more complex network for synchronization, or synchronizing and coordinating all these sources and consumers of power. The other driver for PTP is really about better synchronization, being able to achieve greater efficiency. So greater efficiency can mean a lot of money to the power industry, and a better synchronization can deliver that greater efficiency, because the better you coordinate consumption and generation, the less you waste, and therefore you have better efficiencies. So PTP in the power sector is being driven by greater efficiencies as well as the need for greater diversity within the power communications networks. The IEEE has, under the C37238 standard, already defined a power profile for the use of 1588, and this has a specified set of rules. Again, documentation is available from Calnex to further expand on this. So the next industry we'll look at is really the enterprise sector, specifically financial markets that use 1588 or PTP for timestamping high-frequency trading. And this has gone on for a while now. However, what is evolving in the financial markets is that there are new regulatory demands from the financial regulators, both in America, in Europe, and also in Asia, to actually mandate more accurate timestamping of that trade. And when you need accurate timestamping, you can deliver that timing and synchronization across the trading network, but that's not yet guaranteed, and so needs to be specified, defined, and tested. And to this end, there is a timing solution via PTP profile being developed for use in the enterprise sector, and that's under the realms of the IETF, which is defining the enterprise profile for PTP. The latest version of this from the IETF from February of 2015 is version 5. So again, an industry that is down the track of defining a use model for PTP within its sector. Let's also look at some other industries which are very interesting, and this is something we've classified as the industrial internet. Now, we classify the industrial internet as the use of the Ethernet and Ethernet for communications in lots of different environments. So we have in-vehicle or in-craft communication, so the connected car, defense communications within a craft are all classified under this banner of industrial internet. An area of broadcast or specifically audio-video bridging in broadcast communication is classified under this. And another interesting area, which is what we call the industrial networks, the industrial networks in automation networks within industrial floor spaces that automate, coordinate, and correlate the operation of machinery. Now, the common thing that all of these applications have across them, which makes us classify it the same way, is really about taking the sensors that exist in these networks, sensors, actuators, and the coordination between them, and driving that coordination communication using PTP. So all of those applications we talked about have, as I say, utilize the use of sensors in them. These sensors need to make measurements which then need to be coordinated and then transferred into the control systems of these networks. So that coordination is increasingly being governed by PTP. So PTP profiles will be required for each of these different applications. And the industrial internet, specifically something called time-sensitive networking, is an interesting area of development to look at. And finally, we'll touch on the broadcast industry, which, in addition to the previous mentioned AVB, is also specifying the use of 1588 for its communication network via the Society of Motion Picture and Television Engineers. Now, the driver for this, quite simply, is broadcast equipment, be it outside broadcast or even a single camera videoing an event. The communication to these devices have a dedicated cable for timing and synchronization called GenLog. Now, this dedicated cable is inefficient and heavy, and therefore the driver is there to put all that timing and sync over the Ethernet, which provides the connectivity to these broadcast stations, studios, and cameras. And so timing over Ethernet, namely PTP, is of great interest to the broadcast industry. And Society of Motion Picture and Television Engineers, or SMPTE, is defining a profile under SMPTE 2059-2, and the last of these, profile for this was approved in March 2015, and the broadcast industry is looking very closely at this. So fundamentally, we've seen a number of industries here that are using PTP and Ethernet connectivity, and the story here is quite simply that from modest ideas of Ethernet providing connectivity, we're now trying to get Ethernet to keep the world in synchronization. So that was a presentation from Calnex Solution. Thank you.